Today we're going to explain Archimedes' principle and how it works. You may have heard it more commonly used as buoyancy, but they are the same concept. Buoyancy is the apparent loss of weight of objects when placed in a fluid. This is what you are experiencing when you play chicken in the pool with your friends. When getting your friends on your shoulders while underwater, their weight seems to be dramatically less than it had above water. This is because of buoyancy force. Think of it as a counter to the force of gravity. Take a look at these diving sticks. When you pick them up from the bottom of the pool, they seem to be of a normal weight, but when you come to surface and bring the diving sticks above water, their weight seems to increase. This is the simplest way to describe buoyancy. When underwater, the liquid's buoyancy force pushes against the gravity force. When brought above water, the gravity pulls down with nothing pushing against it, making it seem as though it was heavier. So now that we've learned what the force of buoyancy is, we can figure out how to determine it. The equation for buoyancy force is Fb equals density times v times gravity. Gravity will always be 9.8 as long as you're solving a problem taking place on Earth. V is the volume of the liquid the object will be placed in. Lastly, density is specific to each substance, but has a great impact. Density will determine whether or not an object will float. If an object floats, that means the density has a lesser value than that of the liquid. Take this wooden cube for example. It floats since the density of the cube is less than the water. Notice the water level previous to the placement of the wooden cube indicated by the pink dotted line. The water rose when the cube was placed in the cup. The amount that rose, called the displaced water, is the volume of the cube that is currently beneath the water. The weight of the cube will also seem to lessen due to buoyancy force. While gravity is pulling down, buoyancy is pushing up, lessening the weight of the cube. When going about solving a problem, it's important to realize that with stationary objects, gravity is equal to the buoyancy force. This, however, is not always the case. If more than one force is countering an object's gravity force, that will be added to the buoyancy force to equal the gravity force. For example, if an anchor is attached to a rope underwater, both buoyancy force and tension are working against gravity. That would make the equation gravity equals buoyancy plus tension.